Hello everyone, I am Emir. I am going to present my project, which its name is Sight, a hybrid IoT and edge vision tracker for mitigating phantom occupancy in university study spaces. My presentation is structured into 5 main parts. First, the motivation behind the project, then our architecture and results construction, followed by the future works of our models, and finally, our demo video. University libraries and study rooms feel constantly full, yet half the desks sit empty. The reason is phantom occupancy. Students drop a backpack, a jacket, or a laptop on a desk to claim it, then disappear for hours to attend a class or take a long break. The result is frustrating for everyone. Turnstile counters say the building is at capacity. Students walking in see rows of unoccupied chairs, but no way to tell which ones are truly free and which ones are just being held by an absent owner. People give up and leave. Existing solutions don't really fix this. PIR or weight sensors on every desk scale poorly and still can't tell a person apart from a bag left behind. What's needed is a system that reasons about what is on the desk, not just whether something is there, and that can release a seat once it has clearly been abandoned. Sight is built to do exactly that. Sight is built around 3 networked actors talking through a single MQTT broker. The vision node is an AI thinker ESP32 mounted overhead. It captures a VGA JPEG every 7 seconds and streams it, base 64 encoded, to the broker. The inference server runs Mosquito and a Python service built on Ultralytics YOLO VI 8N. For every incoming frame, it crops each desk's region of interest, classifies it as empty, occupied, belongings _only, or abandoned, and publishes the result back to the broker as a retained message. The kiosk node is an ESP32-S3 with an RFID reader and a small OLED display. It subscribes to the desk state topic, so the moment a student taps their card, the kiosk already knows which desks are truly empty and assigns the first available one, published as a check-in event. Every link uses a deliberately chosen quality of service level. Frames are fire and forget. Desk states are at least once with retain enabled, so a rebooting kiosk gets the latest state instantly, and check-in events are exactly once, so no seat is ever double allocated. A web dashboard subscribes to the same broker and renders a live desk grid for staff visibility. No extra plumbing, just one more MQTT client. Here the desk is physically empty, no person, no belongings. The overhead camera frame on the left confirms it, and at the bottom you can see the dashboard updating in real time. The desk card flips to available within one capture cycle. This is the state the kiosk reads when a student swipes in, so the seat that gets allocated is genuinely free. Now a monitor and a keyboard sit on the desk, but no person is present. This is the classic phantom occupancy case. Sight recognizes the configuration. Belongings detected, no person detected, so the dashboard transitions to on break. From this state, a countdown begins, and if no one returns within the timeout, the desk is released as abandoned. Exactly the failure mode that traditional sensors miss. Finally, when a person is detected at the desk, the state moves immediately to in use. You can see the camera catching the user on the left and the dashboard syncing at the bottom. There is no ambiguity now. The seat is actively being worked at, the kiosk will not allocate it, and any prior break timer is cleared. The same MQTT pipeline drives all 3 transitions. Only the YOLO classification on each frame changes. Three directions extend this work. First, a fine-tuned detection model. The current prototype relies on off-the-shelf YOLO V8, trained on generic COCO classes. Library belongings, laptop sleeves, pencil cases, stacked books, have their own visual signature. Building a small in-domain dataset and fine-tuning the detector would tighten the belongings only state and reduce misdetection flicker further. Second, lab integration. After the library deployment, the same system can be rolled out to faculty study labs. The architecture is domain agnostic. Only the desk regions and the kiosk placement change. This brings the same phantom occupancy benefits to spaces where lab equipment, not just bags, signals a reserved seat. And third, a mobile companion app. Right now, the dashboard lives on a desktop browser inside the library. Because every desk state is already published over MQTT, a lightweight phone app can subscribe and show students a live availability map before they walk in, saving the trip when the building is genuinely full. Together, these 3 steps turn the prototype into a deployable, data-driven service for everyone who uses university study spaces. Here is a short clip of our prototype in action. It's a quick demo, but it shows the 3 states transitioning live and the kiosk reacting to a real RFID tap. Here is a short clip of our prototype in action. It's a quick demo, but it shows the 3 states transitioning live and the kiosk reacting to a real RFID tap.